12 milliseconds, then 400. Nothing changed. You look for the bug. It looks fine. That's when you realize you weren't looking for a bug. You were missing a picture of what's actually happening. That's what this video is about. Most developers learn about connections, but there's a question almost nobody asks. Between a connection becoming ready and your code actually running, what happens in that space? Something does happen there, and understanding it changes how you see every async system. The kernel watches your connections. When something is ready, it tells your application. That's ePod. Knowing what's ready is only half the picture. Each ready connection becomes work. Read this, pass this, respond. Each one becomes a task. Tasks don't run immediately. They wait in a queue. Something runs those tasks. That's the event loop. It keeps moving. Pick a task, run it, pick the next. But there's a rule. One thread, one task at a time. No interruptions. That rule sounds simple. The consequences are not. So, like, think a kitchen. One chef, one pass. Orders comes in. They line up, one at a time. One dish, 40 minutes. Everything else waits. Nothing is broken. It just occupied. That's the event loop. Everything behind it waits. From outside, it looks random. 12 milliseconds, then 400. The code didn't change. One task held that thread, and everything after it waited. Each task gets the thread, does its work, gives it back. When that happens, the system flows. When it doesn't, everything waits. Tasks need to be short, not as advice, as a rule. But some work cannot be made fast. Hashing a password, processing a file, a heavy calculation. They take time. That's all there is to it. If they run inside a loop, they hold it. In Node.js, this is the most common reason performance breaks in ways that are hard to trace. The code looks correct. It is just running in the wrong place. The system draws a line. Fast work stays. Slow work leaves to a worker, a separate thread running on its own. The loop doesn't wait. It keeps moving. When the worker finishes, results come back. Loop picks it up like any other task. Same kitchen, chef doesn't wait at the pause for an hour. Different station, pause keeps moving. The event loop is not a processor, it's a coordinator. It decides what runs. It hands off what is slow and keeps moving. You stop asking, what does this function do? And start asking, how long does this hold the loop? That second question is how async actually clicks. Kernel tells us what's ready. Tasks enter a queue. Loop runs them one at a time. Slow work moves to workers. Each pod does one thing. Single thread, enormous load. Not by doing everything at once, by never waiting when it doesn't have to. Most developers don't think about this. That's fine until it breaks, until the system slows, and nothing explains it. At that point, you don't need more code. You need to see it clearly. And now you do. One more thing. When you write an async function, which part is actually the task? Most developers don't have precise answer. That gap is exactly where async bugs live.